Welcome to lesson 1.2. In this lesson, we'll be learning about measuring segments and constructing segments. So you will need a couple of pieces of material. The very first piece of material that you will need is a protractor. You will also need a compass. Along with this, you're going to need a half sheet of paper, preferably a blank piece of white paper. All you have to do is just grab your regular 8.5 by 11 and cut it in half. Also, you will need a sixth of graph paper. Now, if you go to my website, I'm going to show you guys a video there. There's a video there that shows you how to cut a paper into 6 equal pieces. So before you watch the video, go ahead and watch that other video, and you will end up with a little piece of graph paper. You're going to grab your graph paper and you're going to cut it up into 6 equal pieces. So you're going to need one of those. So I will tell you guys where everything's going to go. Now, this is on page 7. Now, we are not going to do this part of the exploration. It's not really that relevant. So I want you to cross it off. Not that important. Okay. The next thing I want you to do is I want you to go to page 8. And you're going to grab that half sheet of paper. And all you're simply going to do is glue it on top of that sheet. Okay, so this is on page 8. And simply glue the paper right on top. Next, go to page 9. And at the top of page 9, you're going to glue the piece of graph paper. And that is for problem number 2. Scroll down to the bottom, and you're going to put example number 1 right there. Turn to page 10, and you're going to be putting problem number 3 right there, and problem number 4 right there. Now let's start with the exploration. So let's go back to page 8. Now on page 8, we are going to do a construction. So what I want you to do on this piece of paper, I want you to grab your protractor and simply divide up the page, not necessarily in half, but a little bit less than half, maybe like 2/3 of the way. Maybe a little more. You need a little more space for that. Okay, so about 1/4 of the way down. Simply draw a line, because that's going to be our separator. Now let me work around the light here. I guess that's the lowest. Okay, give me 1 second. Okay, I'm closing down the blinds in the room. All right, so at the top of this piece of paper, we're going to do our first construction. And our construction is called copying a segment. And that's our first construction that we're going to do. So it's a very simple construction. All you have to do is draw a segment, and then we're going to copy it. All right, so grab your protractor and simply draw a segment of any length. Like, don't even measure it, just draw a segment. Now, once you do that, I want you to label both endpoints. We're going to call that endpoint A, endpoint B. And our job is going to be to copy this segment. But what we're not going to do is we're not going to measure it and then go down here and just draw the same line, because that is not a construction. So what we're going to do is we're going to copy segment AB. Okay, so in order to do this, you need to do this first. Select an endpoint and that's going to be the copy of A. So we're going to call that A prime, getting us introduced to notation. Now from A, I want you to draw a line that is visually bigger than segment AB, just bigger. How big? Who cares? Just bigger. Now, what you're going to do is with your compass, okay, now in the compass, you got the little metal piece and you got the pencil. And you're going to use that to measure the length of the segment. So measure the length of the segment. And I'm going to measure it it's about this big. Will there be a little error? Yeah, it's okay. So from A to B, you measure segment AB. You pick up your compass and you slide it down to A prime. Okay, put some weight on that A prime and simply draw a little arc. Okay, once you have that, look where that arc intersects that line. Mark it as another endpoint, and we're going to call that endpoint B prime. And you are done. You have copied segment AB, and you now have segment A prime, B prime. And they both happen to have the same length. So there's notation for that. When two segments have the same length, we call them congruent. So in this segment, this example, you have segment AB, congruent, that's the symbol for congruence. It's a little equal sign with a little squiggly line at the top. Segment AB is congruent to segment A prime, B prime. Okay, so we call, whoops, my prime is way too big. So this symbol right here, like we said, stands for congruent. Now, what does that mean? It means that the lengths are equal. Okay, so the fact that these two segments are congruent, that implies that segment AB is equal to segment A prime and B prime. Now, if we wanted to measure this, we could simply grab a ruler and measure it. Now, if this was in the coordinate plane, meaning that if it was in an X and Y axis, we can't really just grab the protractor and then measure the line, unless it's on a horizontal or a vertical and the coordinates are on, just real numbers. So we have another alternative for, finding the distance between 2 points in a graph. It's probably new to you guys or probably not, but it's this one. And we will be coming back to this in a lot more detail later on. It's called the Pythagorean theorem. Now, what does the Pythagorean theorem has to do with anything on a graph? Well, that's the distance formula that we're going to cover in a lot more detail later on. But to understand, what is the Pythagorean theorem? In the Pythagorean theorem, you have to have first a right triangle. Okay, a right triangle has a right angle of 90 degrees. The two sides that make up that right angle are called the legs, which we're going to call A and B. And the segment across the right angle is called the hypotenuse. We're going to call that C. So you might remember it, A squared plus B squared equals C squared. Okay, why am I mentioning it? Because we are going to need it later on. All right, so let's go ahead and move on to page 9. Now, let's go over some additional information about the ruler postulate. Now, I really don't care if you don't remember the names of these, but at least try to understand it, okay? So what exactly is the ruler postulate? The ruler postulate is like the blend between the straight line and the number line. Is what allows you to literally have a ruler as a tool of measuring. All this is a bit of technical detail. But what are rulers used for? Rulers are used for measuring. You start one point, you put it at another. Usually you start at 0, and then you measure, the length of a segment, which is kind of what we're going to do. But in this case, we're not going to be measuring at 0. How does that work? Very simple. We're going to do it right here. So what I want you to do is I want you to draw a small line. Doesn't matter how big. And what we're going to do is we're going to measure it. Okay. Normally, we would measure, and I'm going to use millimeters just to be a little bit more exact. Normally, we would put the 0 right there on the millimeter, on the little dot, and then we would measure it. But that's too easy. Let's make it a little complicated. Let's move it to a place where this point is on, literally could put it anywhere, but I'm going to put it on the 5. Okay, so there's 5 millimeters. So the location of this is 5 millimeters. The location of the first starting point is at 1.1 millimeters. So how big is the segment? Well, that means that we're going to have to subtract. We're going to have to subtract 5, take away 1.1. So I'm going to have to do a little bit of borrowing. Okay, 5 take away 1.1. That's going to be 3.9. Now, if I were to measure it normally, I would get about 3.9. Okay, you can see that? It's about 3.9. So the reason why I want you guys to do it like this is because I want you guys to understand that the distance between 2 points is the difference between the large number and the small number. All right, let's take a look at the next page, and then after this, we'll go back to the examples. All right, we kind of already went over this. Okay, congruent segments. Line segments that have the same length are called congruent segments. You can say the length of AB is equal to the length of CD, or you can say that AB is congruent to CD. And the equal sign with a little squiggle line on top, it means congruent to. So in this diagram, you have segment AB and segment CD that are congruent. Now, I want you guys to pay attention to this little line that is right here. How do you mark two segments congruent? Okay, we use these little hash marks. So here, segment AB and segment CD are congruent. Therefore, they have equal lengths. Okay, so AB is congruent to CD, therefore their lengths are equal. Now, if you were to have a small segment and then a larger segment, or even the same size, and you put them together, you get a really, really bigger, much bigger segment. Which brings us to our next major idea called the segment addition postulate. Okay, so in this example, if B is between A and C and AB and C are collinear, the length of AB plus the length of BC equals the length of the whole segment. Also, if you know the distance of AC and you subtract the distance of BC, you end up with AB. If you know the distance of AC and subtract the distance of AB, you end up with BC. Okay, so this is called the segment addition postulate. Let's go ahead and start the examples. Now, our first example is on page 9. Okay, so here is example number 1. It says measure the length of ST to the nearest tenth of a centimeter. So what we're going to do, now here's the thing, when you guys are copying this, you're obviously not going to know what length it is because it's on a video. Simply draw a segment of any length. Probably anything smaller than 10 centimeters will work. So what I'm going to do is I'm going to just randomly put this ruler anywhere where my second endpoint is at an integer. Could you do it somewhere else? Absolutely. You just have a little more decimals to work with. As a matter of fact, let's do that. I'm going to do that. So I say this is at 7.4. Okay, so this is at 7.4. and S is at, it's about 3.1. So what is the length of this segment? It's the difference between those two. 7.4 take away 3.1. Subtract, and the length of my segment is 4.3. Yours might be different depending on how long you made your segment. But the idea is pretty much the same. Don't worry about if your numbers come out different. They should come out different. That's okay. So that's example number 1. Example number 2. Now this is in the graph. Do you need to write down the points? No, you do have to plot them though. Now, first thing we're going to do is we're going to plot them. The first is J, -3, 4. Okay, so here it's 0, 1, 2, 3, and up 1, 2, 3, 4. That is where my J is. When you guys are graphing, don't just put the points. Actually put the point and the letter assigned to that point, J. The next one is 2, 4. 1, 2, 1, 2, 3, 4. And that is K. Always use uppercase letters when you are plotting points. 1, 3. 1, 1, 2, 3. That is L. And then the next one is 1, -2. That is M. So now they want to know, are JK and LM congruent? If you look at JK, if you were to draw that segment, okay, JK, because it's on a horizontal, we can simply just count. 1, 2, 3, 4, 5. JK is 5 units long. And LM, that's 1, 2, 3, 4, 5. Okay, let's double verify I did this right. -3, 4, 2, 4, 1, 3, and 1, -2. Okay, so here's 5 and here's 5. So as you can see, these two segments have equal lengths. Therefore, JK is congruent to LM. If these were not the same length, then they will not be congruent. All right, let's look at example number 3. Now remember, if I'm going a little too fast, make sure you pause the video so you can take notes. I'm trying to keep the videos as short as possible. Using the segment addition postulate, find the distance of DF. Now DF is made up of two segments, segment DE and segment EF. Okay, so segment DE plus segment EF is equal to the measure of segment DF. So what is the measurement of DE? DE is 23. EF is 35. So how much is DF? DF is going to be the sum of those two. 23 plus 35 is going to be 58. So DF is 58. Now here's the same idea. Okay, FG plus GH is equal to the whole segment FH. Now looking at the diagram, what information do I have? I'm looking for GH. What is the length for segment FG? FG is 21 units. We do not know what GH is, but we do know what FH is. FH is 36. So our goal is to solve for GH. So what we're going to do is we're going to subtract, and GH is equal to 36 minus 21, which happens to be 15. So GH is 15. Now for the last example, now in this one, obviously I don't want you guys to draw the map, but I want you to draw the segments that are in here, like pretty much this way. The cities shown on the map lie approximately in a straight line. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. So pretty much from here to here, what is that distance going to be? Now we do know that from Lubbock to Tulsa, that distance is 377 miles. We do not know how far it's from Tulsa to St. Louis. That's what we're looking for. But we do know that from Lubbock, hope I'm saying that right, to St. Louis, the distance is 738. So we know the sum of these two is equal to that one. So 377 plus our unknown equals 738. Now you're probably saying, why can't I just subtract them? Yeah, you can. But I'm showing the full detail for those that don't understand. Why do you subtract? Sometimes it's better to over-explain than to under-explain. So when you subtract, you get 1, that's 7, 8, 9, 10, 11, 12, 13, that's 6, 161. So if I ever do make a mistake, you get cool points if you correct me. Okay, so the distance is 161. And ladies and gentlemen, that is the last example. Please make sure to complete the extra practice on your student journal. Have a great day.